So we're estimating probabilities, and we're doing that by collecting data. So let's come up with a definition, or let's explore our definition of what probability is. Okay, so in the last video, we were pretending to spin the spinner. I did that for you, adding the sums. What we were doing is we were performing a chance experiment. We had 4 equally likely outcomes. Okay, so we were just spinning the spinner and seeing what happened. It says you can reuse the results from a chance experiment to estimate the probability. So a lot of times when we collect data, we're using that data to make predictions about something else. Okay? So here's what we have here. Okay? We have the probability of the sum of getting greater than or equal to 5. So remember, we spun it 15 times. We counted how many times the sum was greater than or equal to 5. Okay? And our probability then is the number of times that happens over the total of observations, the total of events, the total of times we spun the spinner. Okay? So when it says the number of observed occurrences of the event, this event right here, this is the outcome we want. The outcome we want. And in this case, it was our sum being greater than or equal to 5. Okay? So we're going to take what we want. And be careful when we say that. All right? Because sometimes we're like, what's the probability of rain happening? And people are like, well, we don't want it to rain, but we're trying to figure that out. Or how many days has it rained? It's not necessarily something like we personally want, but the event we're looking for. And then out of the total number of times, total number of observations. Okay? Event, occurrences of the event, out of total times. So, based on your experiment of playing the game, what is your estimate for the probability of getting a sum of 5 or more? Well, if you remember, how many times did we get 5 or more? We got that 8 times. So, probability of a sum greater than or equal to 5. How many times did what we want to have happen occur? 8 times. What was our total number of times? 15. Now, if we type that into a calculator, 8 divided by 15, we get 0.53 repeating, right? So that equals 0.53333. Okay? So we can write it as a fraction, we can write it as a decimal, or guess what? We can write it as a percentage. Stop for a second. I'm going to say approximately equal to 53.3%. Okay? Because this is 0.53 repeating. Okay? Occurrence of the event happening out of total. Based on your experience playing the game, what is your estimate for the probability of getting exactly 5? A sum of exactly 5. So our probability of our sum being equal to 5, well, how many times did that occur? So exactly 5 in our experiments, right? Our observations of spinning the spinner, or what I pretended to do, we had 3 times. So when we want the probability, place that with a P, of getting a sum of exactly 5, that happened 3 times out of the total number of observed occurrences of the event. Sum of 5. How many times did that happen? Out of total, 15. Okay? So again, 3 15s, you can leave it like that. 3 divided by 15, 0.2. Actually, I shouldn't say leave it as a fraction. Change it to either a decimal or a percent. Don't leave it as a fraction, okay? Because we kind of want to normalize it, meaning if we spun the spinner 20 times, I don't want it to be out of 15, okay? But if we turn it into a decimal percent, we're kind of making them all the same form, okay? That's what we're doing now, right here. Okay, we're going to start based on some observations. We are going to start creating some probabilities. Animal crackers. So a student brought in a very large jar of animal crackers, yum, and he's going to share them with class, he or she. Rather than count and sort all the different types, randomly chose 20 crackers and found the following counts: 2 lions, 1 camel, 4 monkeys out of 20. Estimate the probability of selecting a zebra. So what is our probability of selecting a zebra? Well, remember, probability is the event we want to have happen, zebra, which is 3 times, out of the total, 20. Changing that into a decimal, 3 just divided by 20, we get 0.15. So writing it correctly, we can write it like that, or we move it over 2 places and we say 15%. So we have a 15% chance of selecting a zebra out of that big jar, if this holds true. Okay, so let's keep using these animals here. And let's just try different percents. What is your estimate for the probability of selecting a lion? So the probability of a lion, remember, is we're going to take how many times the lion occurs? 2 out of the total, 20. 2 divided by 20 is 0.1. Or move it over 2 times, and that's where we have to add a 0 in there, and we get 10%. You're going to notice that we keep doing the same thing over and over, but our numbers are changing because, well, our top number is changing, our bottom number isn't, because that's our total. And we're using the same information right here. So the probability, P, of selecting a monkey. Well, how many monkeys were in our sample here? 4. How many total were in our sample? 20.2. So that equals 0.2, or move it over 2 times and add that 0 in there, 20%. And again, I don't care if it's a decimal or a percent. All right, how about a penguin or a camel? Okay, so we want the probability of a penguin or a camel. So now we have to take our combined probability there, okay, because we can do either or, okay? Can't do both. They can't be both a penguin and a camel. But we're okay if we select a penguin, which was 3, or a camel, which is 1. So that's going to be a total of 4 out of our 20. Okay, because it doesn't matter which one we pick. So we have a total of 4 things, 4 events that we want out of that jar of animal crackers. If you change that to a decimal, 0.2. Or again, guess what? That's 20%. All right, so what is our probability of selecting a rabbit? All right, so according to our sample here, rabbit occurred lion, camel, monkey, elephant, zebra, penguin, tortoise. 0 times. So guess what that is? 0 or 0%. Certain, impossible to pull a rabbit out of the sample. Out of the sample, right? The whole big jar could have had some rabbits in there, but we're just going out of here. Is there the same number of each kind of animal in the jar? No. Okay. If we look here, it seems like elephant is our largest one, right? So I'm just going to say it appears, but remember, this is a sample. It appears there are more elephants than anything else. We don't know that for sure because there's a lot more things in there, but we're only going on the information we have, right? This is the information we have. That's all we can use. And that's the thing with probabilities. You are making some observations. You're collecting some data. That's what you're going on, okay? That's why it's not guaranteed, okay? So if the student selected another 20 animal crackers, would we get the same amount? Well, if you think of our probability words, it's kind of unlikely, okay? But it is possible, okay? It is possible to grab the exact same amount. Probably not, right? But it's possible. So if there are 500 animal crackers in the jar, how many are elephants? Well, first of all, find the probability of its being an elephant. So the probability of an elephant is 5 out of 20, which is a decimal, that's 0.25. So what you do then is if you want, kind of like before, right? If this is our total when we were doing percents, you change a percent to a decimal and then multiply it by the total, right? And if you go 0.25 times 500, you get 125. So there's 25% of 500. That equals 125 elephants. Okay. So this is kind of like what we were doing with percents, right? We changed 25% into 0.25. Then we'd multiply it by the total, the of part, right? Out of, like this is saying 25% of 500. Okay. So probability of an event occurring is going to be how many times it happens, the event, what we want to happen out of total. So the data we collect, we can use to create probabilities to make predictions about the future.